Hi, and welcome to day 4 of functions. Today we are going to be talking about composite functions or compositions of functions. The first thing we're going to do though is review the domain and the range. The domain for y equals negative x squared plus 1 is the set -3 less than or equal to x less than or equal to 3. That, remember, includes everything between -3 and 3. What is the greatest value in the range? Well, like we talked about before, when you're given the domain, substitute your values in to get the range. So I would go from -3 all the way down to 3. I'm going to have to finish it over here. Okay, and then my x's are my domain, and my y's would be my range. Now, there's several ways I can do this. The easiest way to do this would be to type the equation into a graphing calculator and get all your values. And if I did that, I'd have -8, -3, 0, 1, 0, -3, and -8. This is still x, this is still y. I'm looking for the greatest value in the range. So that means what is the largest y value I get when I restrict my domain to -3 to 3? If I'm looking at my y values, I have -8, -3, 0, 1, 0, -3, -8. 1 is my largest range value, so therefore the answer is actually just 1. Now, if you remember, -x squared plus 1 is a parabola. Because the a value is negative, it's going to open down. If a is negative, it's a frown, so my parabola opens down. So this would be the parabola. And this is the point here, would be our 0, -1, and this is our vertex. So if you know how to find the vertex of a parabola, that's the only point you would have needed to find for this. Okay, composite functions. This means one function follows another. And we have two different notations to look at right here, but they both mean the same thing and say the same thing. They both mean function f follows function g. You work backwards. So what you see second, it comes first, and it's read f of g of x. So when it's written the top way, you use the second function first. When you're looking at the bottom one, you do what's inside, work your way inside out. Okay, so f of g of x equals f of g of x. They are exactly the same. They're spoken exactly the same. They just look different when you write them. So for number 1, if f of x equals x squared and g of x is equal to x plus 1, find f of g of 3. So what that means is I'm going to work with the second function first, and I like to rewrite them as f of g of 3. By rewriting it, that lets me know where I'm working from. I'm working from the inside out. And I'm going to take 3 and put it in place of x in g. So we'll find g of 3 first. So I'd have 3 plus 1, which is equal to 4. Now I take my answer from g and I substitute it into f. And f was x squared. So we're going to find f of 4 which is 4 squared, and that would be equal to 16. That is my final answer. So this is different from what you did before. You're using two functions, you substitute into one function, find the answer, and then take your answer to use it to substitute it into the other function. Where before we were always substituting the same value into both functions and finding the new answers. For B, it says find the rule of composition. Anytime you see the rule of composition phrase, that means you're not looking for a single number. You will have variables in the answer. Whereas before in part A we had a single number, here the rule of composition, whenever you just see f of g of x, I'm going to rewrite that. Okay. By rewriting that, I know I'm going to start with g, and here I have just an x where before I had a number in its place. So that's how I can tell the difference between the two problems. And g of x is what I'm starting with because that's on the inside, and it's equal to x plus 1. F of x is equal to x squared. So I'm going to take this x plus 1 and put it in place of x in f of x. So that means I will have f of x plus 1 equals x plus 1 squared. And what that nice little squared symbol means, it means I write it twice. So x plus 1 times x plus 1. And when I multiply here, I will get x squared plus 2x plus, plus 1. Okay, so plus 1. This right here, this x squared plus 2x plus 1, is my rule of composition. Now, when I find the rule of composition, what it allows me to do is answer a problem like A in one step. So if I were to do problem A and find f of g of 3, but use my rule of composition, if I put in 3 in place of x, I would get 3 squared, which is 9, plus 2 times 3 is 6, 9 plus 6 is 15, plus 1 is 16. So that's how we can check to make sure we did our rule properly, is if we have a problem like part A. Part C is g of f of 3. So this time, g of f of 3 means I'm going to take f first. So f of 3 equals 3 squared, which is 9. Now I'm going to take g of 9, and g was x plus 1, so I'm going to put 9 plus 1 in its place. So my answer is 10. And that's the answer I'm looking for. Substitute in the f first, get your answer, take your answer, put it into g, get your new answer. Okay, for D, for the rule of composition, this is g of f of x. So I'm going to take f of x first, and f of x is equal to x squared. And then I'm going to take g of x, which is equal to x plus 1. And I'm going to take x squared, and put it right in place of x. So g of x squared would be, where I see x, I'm going to put x squared plus 1. That is my rule right here. Now, if I want to check that, if I want to find f of g of 3, my answer should be 10 by using my equation in D. So if I put in 3 for x squared, I'd get 9. 9 plus 1 is indeed 10. Okay? For number 2, if f of x is equal to 1 over x and g of x is equal to 2x, find g of f of x. So g of f of x. So that means I'm going to take f of x first and substitute it into g of x. And because this here is an x, that means I'm finding a rule, and I'm going to have variables in my answer. So f of x is equal to 1 over x, and g of x is equal to 2 times x. So what I need to do is take 1 over x and put it in place of x. So that will be g of 1 over x is equal to 2 times 1 over x. And then I just need to clean up what that looks like, and that will give me 2 over x. So g of f of x is equal to 2 over x. For number 3, if f of x is equal to 6x and g of x is equal to x minus 3, what is f of g of negative 3? I have negative 3 here. That means I'm going to have a numerical answer. And g is on the inside, so I'm going to start with g first. So I'm going to find g of negative 3 equals negative 3 minus 3, which is negative 6. Then I'm going to take negative 6 and put it into f wherever I see an x. So I have 6 times negative 6. So my answer is negative 36. For number 4, if f of x is equal to x plus 4 and g of x is equal to negative 2x, find f of g of 1/2. Good news is I have a number, therefore I will have a numerical answer. And g is on the inside, so I'm going to substitute 1/2 into g first. So g of 1/2 is equal to negative 2 times 1/2. And remember, that's a 2 over 1. So negative 2 over 1 times 1 over 2 is going to be negative 1. Now I'm going to take negative 1 and put it into f. So it's negative 1 plus 4, which is 3. So my final answer is 3. For number 5, if f of x is equal to x minus 2 over x plus 1 and g of x is equal to x plus 1, find g of f of 0. So g of f, okay, there we go, of 0. So I'm going to take 0 and put it into f first. So f of 0 is going to be 0 minus 2 over 0 plus 1, which will give me negative 2 over 1, which is negative 2. Now I'm going to take negative 2 and put it in place of g. or in place of x in g. So it's g of negative 2 would be negative 2 plus 1. And negative 2 plus 1 is negative 1. So my final answer is negative 1. So the key to working with composition of functions is knowing that you either start on the inside function and work your way out, or you start with the second function and work your way backwards. All right, we will see you in class later.